So here we are going to look at the sections 6.2 and 6.3. These are looking at right angles. So incorporating triangles to the discussion that we've had so far with the unit circle. So here I have an angle in this triangle, say theta, and I have to answer some questions. So say I want to find the cosine of that angle theta. So what we've thought about so far is we said, well, if we were thinking about a unit circle, we said, well, the cosine is just the x-coordinate of the point on the unit circle. But the idea with this section is, here we're going to actually think about, well, what if this triangle has sides of length, say 8, 15, and 17. So the way I kind of like to visualize this is I just start out by thinking, well, actually, all the problems we've done so far, where we were thinking about the unit circle, could really think of this triangle as being inscribed inside of a circle. So if you think of it that way, all the problems that we've done so far, since they were on the unit circle, the hypotenuse of the triangle here would have been the radius of the circle, so that would have been, say, 1. So to generalize this discussion to triangles that have a hypotenuse with a length other than 1, what I can actually do is say, instead of this cosine just being x over 1, what if I say it's the x over the hypotenuse? So thinking about this angle, another way to say that is the cosine of this angle is the adjacent side over the hypotenuse. That's another way you could think about it. So let's see, in this case, the cosine of the angle theta would be then what, 8 over 17? So notice that cosine is still a value smaller than 1 in magnitude. So we can do something very similar for sine of theta. So that would be the y value. Instead of just being over 1, it would be over the hypotenuse. So the y value, we could also think of that as the side opposite to the angle over the hypotenuse. So for this particular triangle, the sine of the angle theta would be what, 15 over 17. Again, that's a value smaller than 1 in magnitude. Let's see, tangent. Well, that doesn't change. That was still the ratio of y and x. So you could think of that, I guess, as opposite over adjacent. Be my definition. So for this particular triangle, that would be what, 15 over 8? And then all my other definitions stay the same. Like, let's see, cotangent of theta, well, that's just x over y. Or again, I can just reciprocate tangents. That'd be 8 over 15. Let's see, secant. Secant was the reciprocal of cosine. So here was my cosine, so I would just flip that, be what, 17 over 8? And then one more, so cosecant is the reciprocal of sine. So let's see, that'd be 17 over 15. me look a little bit at, what about something like this? So here's a triangle. Let's see, I know this side is 8, and this side is 7. So say I wanted to find a couple things, like say I wanted to know what is cosine of the angle theta. Well, I know I need the adjacent side, the x side, over the hypotenuse. So the thing is, well, in this case, I'd actually have to fill in the missing length x here. So I could actually do that using the Pythagorean theorem. So x squared plus 7 squared equals 8 squared. So assuming for now we're thinking of triangles in quadrant 1, we're going to extend some of this later to triangles in other quadrants. Well, let's see, I subtract, take the square root, assuming I have something like this here in quadrant 1. We'll go with the positive value. So let's see, cosine would just be root 15 over 8. What about, say, well, the sine? Well, that would just be 7 over 8. It's very easy. I don't know, I don't really want to do all of them. Let me do one more. Tangent, that'd be 7 over root 15. So something like that, we would rationalize the denominator. Be 7 root 15 over 15, say. And then we could find secant, cosecant, cotangent just by reciprocating these. Okay, what else? How about, what is the missing side x? Okay, so here's a number 1. So I have 12 here, and say I know I have a 45-degree angle here. So in this case, the side I'm looking for is actually the hypotenuse. So we're thinking of x here as being the variable, not actually corresponding with the side, the horizontal side, say. So I guess the appropriate trig function that I could choose here would be, looks like sine, because you see how if I set up the sine of 45 degrees here, that's the y side, the opposite over the hypotenuse. But the thing is, I actually know the sine of 45 degrees. So therefore, don't I know the sine of 45 degrees is root 2 over 2? So don't I have something like this? What if I cross multiply? So root 2 times x is 24. So x is 24 over root 2. Rationalize. 24 root 2 over 2. 12 root 2. And then I have my x side. Let's see. What else is there? How about 60 degrees? How about x and 13? So still looking for the side labeled x. So in that case, it does correspond with the horizontal side. The other piece of information I have is the hypotenuse. So I'm thinking, what if I set up the cosine of 60 degrees? That would be the adjacent over the hypotenuse. So this one's actually even easier. let's see, so what is cosine of 60 degrees? Well, 60 degrees is pi over 3, so the cosine would be a half. So the x is just 13 over 2. Okay, so say I know a piece of information. Say I know cosine of theta is 5 over 6. Let me think about a quadrant this time. So let me say that the angle theta is in, say, quadrant 4. And let me see if I can find sine of theta, tangent of theta, etc. So the thing is this, I like to start by kind of thinking, I like to think about the circle. So cosine is positive. In other words, the x is positive. So there are actually two places where cosine would be positive. One in quadrant 1 and one in quadrant 4. So that's why I need another piece of information. So if I know theta is in quadrant 4, I know I'm actually thinking of this triangle here. So you can kind of set it up. I mean, thinking about this triangle in quadrant 4. So what do I know? I know the cosine is 5 over 6. Well, the cosine is the adjacent over the hypotenuse. So this is my triangle. So if I want to find sine, tangent, etc., all I need to do again is fill in the length of this y side, the vertical side. So again, I can do that using the Pythagorean theorem. So let's see, I'd have 5 squared, so 25 plus y squared equals 36. So what is that? Plus or minus the square root of 11. So this is where I need to know the quadrant. So because I know I'm in quadrant 4 as opposed to quadrant 1, I actually know the y side here would be negative. So it would actually be the negative square root of 11. Knowing that, I can fill in all the other values very easily. So let's see, sine of theta, that would be the negative root 11 over 6. Let's see, cosine I had. Let's see, what would tangent be? That'd be y over x, negative root 11 over 5. And then I don't know, should I do the others one more time just for fun? So secant, flip cosine, that'd be 6 over 5. Let's see. Cosecant, flip sine. That I have to rationalize. And then cotangent. So that'd be negative 5 over root 11. Rationalize again. And then I guess I have all the information. So should I do one more like that? So this one's slightly different. Let's see. So what if I know tangent of theta is 5 over 3? And I know cosine of theta is less than 0. Again, my goal will be to find, sine of theta, cosine of theta, etc. Okay, so again, first thing I would need to do is I'd need to think about the quadrants. So I always find it kind of helpful to think about a circle here. Let's see. So I know tangent is positive. So that would limit me to 2 quadrants. In quadrant 1, tangent would be positive because x is positive and y is positive. So if I divide those, tangent would be positive. So that's a possibility. The other quadrant where tangent would be positive would actually be quadrant 3, because in quadrant 3, x and y are both negative, so if I divide those again, I get a positive number. So then I have to look at the other piece of information. So here I know cosine is less than 0. So that would mean my x has to be negative. So that means I must be in quadrant 3. So the triangle I'm interested in is actually this one here. Okay, so my tangent. Well, my tangent is my y side over my x side, but again, I'm in quadrant 3. So both of those coordinates would have to be negative, right? Because if I divide, let's see, -5 over -3, I get positive 5/3. So now I can fill everything else in. So let's see what would be cosine of theta. Well, I guess I'll need the hypotenuse, huh? So one more step. Or should I put the step here? Just the Pythagorean theorem, right? So -3 squared plus -5 squared is h squared. So what is that, root of 34? (34), 17 times 2, so this can't be reduced. So the hypotenuse is always a positive number. We're thinking of that as a distance. The x and y can change sign depending on which quadrant that I'm in. So now I just fill all this in. So this would be -3 over root 34. Rationalize that. Let's see, sine of theta, that'd be -5 over root 34. -5 root 34 over 34. Let's see what else. We had tangent, so cotangent, be very easy. That would just be 3 over 5. And then let's see, I guess, secant. Secant, I just flip cosine, so I would just flip this. So that would just be -root 34 over 3. Cosecant, I flip sine, so -root 34 over 5. There are those then. How about a little application problem? The angle of elevation to the top of a cliff is 30 degrees from the ground at a distance 20 feet from the base of the cliff. What about a question like, find the height of the cliff? So I guess let me just show you for a second here. If I'm thinking about angle of elevation, I'm thinking like if I'm standing, on a flat surface like the ground, an angle of elevation is how far do I have to look up from that horizontal to to see, say, an object up here in the sky. So this is an angle of elevation. An angle of depression is just the opposite. So that one would be, I'm standing on the top of something, like say a cliff. Then I'm thinking from the horizontal, how far would I have to look down to see an object that's, say, down here on the ground? This would be the angle of depression. So if I'm thinking of an angle of elevation problem, I'm always starting with this triangle, versus an angle of depression problem, I'm starting with this triangle, the upside down triangle. So let me look back at this one. This one was the angle of elevation. So I'm going to start with a right side up triangle. Let's see what I can fill in. So the angle of elevation to the top of a cliff, so I have a cliff here. Here's the top of that cliff. I'm standing here, say, and I'm thinking, okay, if I was to look up at the top of that cliff, my angle of elevation is 30 degrees. And then it says, at a distance 20 feet from the base of the cliff, not from the top. So this is 20 feet. And then it says, find the height of the cliff. So I'm looking for this height. So then let's see what would be appropriate. I guess I could use, tangent, because I'm looking for the opposite. I know the adjacent. So let's see if tangent will work for me. So tangent of 30 degrees would be opposite over adjacent. Okay, now I know tangent of 30 degrees. So let me get this scratch paper here again. So let's see, let me think about tangent again for a second. Here's 30 degrees, right? That was pi over 6 in radians. So I know the terminal point there was root 3 over 2 1/2. So if I compute the tangent of 30 degrees, I'm dividing 1/2 by root 3 over 2. So that's 1 over root 3. So I rationalize. It's root 3 over 3. So back over here then, I know the value of tangent is root 3 over 3. So I guess I could just multiply this 20 up. So the height would be 20 root 3 over 3. And then what were the units? Feet. So the height of that cliff would be 20 root 3 over 3 feet. Okay, how about something where I need to actually solve the triangle? So, in other words, when they say solve the triangle, that means I need to fill in all information. So fill in all sides and angles. So you can see in this triangle, I know one angle, two angles, one side. So I need to know this side, and this angle. Well, actually can find this angle here very easily. So I can find this angle because I know a fact about triangles. So I know the angles in a triangle add to 180 degrees, or in radians, add to pi. So this is a geometry fact that I know. So using that fact, I can find this angle immediately. So I don't know, say I give this angle a name. I'll call it C. Pick some variable. So I know if I add these angles, so pi 8 plus, this is 90 degrees, it's pi halves, right? Plus my angle C, that has to add to 180 degrees or add to pi. So then I guess I need an LCD. So let me see, this is 4/8 plus 1/8. Let's see, I have 5/8 pi plus C. I guess 1 pi is 8 pi 8. So my angle C would be, let's see, 8 minus 5, 3 pi 8. Okay, so there's my first piece of information. Let me see what else I can find out about the triangle. So how about this x side? Okay, well, what if I do cosine again? So cosine of pi 8 would be the x over 5. So x would be 5 cosine of pi 8. It's pretty easy. What about sine? Let's call this side y. So sine of pi 8 would be y over 5. So y would be 5 sine of pi 8. So do I have everything? I mean, I can draw the triangle here and kind of label. Let's see, I had pi 8, right angle, 3 pi 8, 5 cosine pi 8, 5 sine pi 8. So there's my triangle completely solved. Now, notice with this one, since pi 8 is not actually a special angle, see how I've left these sides in terms of cosine and sine of pi 8? So I don't want to do another entire example, but I don't know. Say I make something up where, like, I know maybe this is, 90 degrees, and say this guy is a special angle. Like, say this guy was 30 degrees. And then say, I don't know, say I know this side is 2. Well, how would I solve this triangle? Well, in this case, let me see, I guess I know. First piece of information, let's see, this is 90 plus 30 is 120, 180 minus 120. This has to be a 60-degree angle then. Then what else could I do? So now I could say something like, let me see, I don't know, cosine. Actually, cosine wouldn't be a good choice. I need something with that's going to use this 2 that I have. So let me maybe leave cosine here for a second. Maybe we'll fill that one in later. But I'm thinking maybe sine would be a better option, since sine is going to involve the opposite side here over the hypotenuse here. So this time I actually know sine of 30 degrees is a half. So I can multiply this up and then multiply by 2. So my h would actually be 4. So you see what I'm getting at here is I actually know the value of sine of 30 degrees. So I actually went ahead and evaluated that one. Oh, I don't know. I guess I should finish this one since I wrote it up here. So I need this side then. So let's see, I know x squared plus 4 equals 16. So x would be root of 12, so 2 root of 3. Assuming still I'm in quadrant 1. Okay, so then, well then let me see here. Cosine of 30 degrees, then we're saying cosine of 30 degrees should be equal to 2 square root of 3 over 4. Let's see if we get a true statement. Oh, look at that. Cosine of 30 degrees is root 3 over 2, so that's kind of cool. So you can see here I have everything filled in on my triangle, 1, 2, 3 sides, 1, 2, 3 angles. So what I'm getting at is, well, when I have the special angles, 30 degrees, say I do go ahead and evaluate sine and cosine. That's why you can see I just have numeric values on the triangle here, versus with this angle pi 8, since that was not a special angle, Actually, on my triangle, I'm left with sides in terms of sine and cosine.